Hello. In this lesson, I want you to recognize the conditions that ensure a quadrilateral is a parallelogram, and I want you to prove that a set of points form a parallelogram in the coordinate plane. This is just the converse of what we did in the last lesson. That is, in the last lesson, I told you the shape was a parallelogram, and then you use some properties to answer questions. Now, this time I'm going to give you a quadrilateral. I'm asking, hey, is it a parallelogram? Well, there are a few theorems that will help us do this. First off, if both pairs, hint, both pairs of opposite sides are congruent, then it's a parallelogram. One pair isn't enough. We'll find that out in a later seminar. If both pairs of opposite angles are congruent, then it must be a parallelogram. If the diagonals bisect each other, that is, they're both bisect each other, then it's a parallelogram. The one that we tend to use a lot is the last theorem here because it only has to do with one side. The only time you can just know something about one side if it's both parallel and congruent. So if one pair of opposite sides are both parallel and congruent, it must be a parallelogram. Here we have a proof of why the first theorem works. Let's go through this. If you're given both pairs of opposite sides are congruent, that is, WX is congruent to ZY and WZ is congruent to XY. Well, then we can see we have two triangles are congruent by side, side, side. That is, triangle ZWX is congruent to triangle XYZ by side, side, side because we know XZ is congruent to itself. Well, then, by CPCTC, we know angle WXZ is congruent to angle YZX. And since WXZ is congruent, those pair of our angles are congruent, and we have the other pair of angles that are congruent. That is, we know angle YXZ is congruent to angle WZX by CPCTC. Corresponding parts of congruent triangles are congruent. Then, because these are alternate interior angles, that makes the lines parallel. And so now we have one pair of sides, both parallel and congruent, and we could actually do it for the other angles too. That didn't look very nice. Try that again. So by alternate interior angles, WX is parallel to ZY. And by the definition of a parallelogram, we know when you have both pairs of opposite sides parallel, that makes it a parallelogram.